Hi guys, welcome to Programming Basics. We're going to start off by having a brief thought about what do we mean by programming, what is it all about, and also what are some of the chief challenges people have. Now I think the biggest issue with programming is the fact it's asking you to think differently about problems. It's making you use part of your brain that you may not have used as much before. Now, give you an example. If I type or write in here 2x equals 10 and you look at it, you might quickly be able to identify that x is equal to 5, right? But if we look at this a bit of algebra, x actually isn't 5. We've taken an abstraction to say it represents 5. Now, certainly I remember a time when I struggled with even basic algebra. And over time, you get more and more used to it until eventually you feel quite confident about algebra. This is hopefully the journey we're going to be on with programming. Because actually, one of the first things we need to learn about is a concept of something called variables. So we could say, for instance, a variable like a person's name. That's essentially a place in memory somewhere. So inside your computer, you could be storing someone's name, Bob or whatever, and all we do is instead of calling it address location X D4F F06 or whatever, which is not exactly easy to remember, we use a symbolic address. So we say, in this case, that's called name. And that allows us to find it. Another really important thing to understand about programming is that it works in sequence. Well, what does that mean? Well, it means it works from top to bottom, just like how you read a piece of paper or a book. You start on the top left. Well, if you're using Western European convention, you start on the top left, you read down, you go line after line after line. Code will be executed in the same way, top to bottom. So why don't we have a go at looking at the basics and get started on this? So, variable assignment. This is a crucial thing we have to get right. On the right, you can see that there are some indicators over here about the correct syntax for the pseudocode. That basically just means this is how you have to write these bits of information out. Underneath that, I've written down a little problem we need to solve. So let's read it. You need to store the details for a user profile. By this, we mean we'd be talking about a Facebook profile. This could be a gaming profile. And in this case, we want to write the pseudocode to store a name, age, and favorite color. Do you know what? I'm just going to underline those crucial things there. So I need name, age, and favorite color. Okay, so what I want to do is I want to think of some suitable names for those variables. So for name, I think I will just use name. The convention I'll use is if it's in green, it's a variable. Then to assign a value to it, we do an arrow, and then we put something in. So how about we do this? We say name Bob. And so Bob is now recorded in name. Notice how I've actually included these speech marks here and here. That's because the data type is a string, and therefore I'm storing it that way. The next thing I want to store is age. Now, age is not going to be a string. It's going to be a number. To be precise, it will be an integer because people express their age as a whole number. Typically, you don't say you're 15.6, you just say you're 15 until the very day you become a year older and then suddenly you're 16. Now I'm going to assign Bob and say he's 21. To assign a value again, I will do the arrow pointing towards it, and this time I'll just write in 21. Notice I didn't have to use speech marks. Numbers don't need to. They stand on their own. We're almost done here. The next one that we need to include is the person's favorite color. Now I'm going to be a bit lazy here. I'm going to do fav, short for favorite, and then I'm going to do something called camel case, because I'm going to fix the two of them together, but I don't know if you notice, I'm going to use a capital letter to make it easier to see they're together. You don't want to use spaces typically in programming, and to get away from using spaces, what you make use of instead is things like this, camel case. Now a color is going to be pink or orange or yellow. Now, is that going to be a number, or more likely it's going to be referenced as a string? So again, to store a value here, we want to put the arrow pointing towards it, speech marks, and we can say pink. And now the value pink, the string pink, is stored in favorite color. This is the very basics of pseudocode. The other thing you might spot here is this concept of a constant. Now the whole point about a variable is we can change it. If at a later point somebody became older, we could say age could now be a different value, and it's maybe 24. The age that was here storing 21, that's now been overridden. It's been overridden by 24. 21 effectively has been removed, destroyed. That memory location that was holding 21 now holds 24. Now with a constant, if you use a constant assignment by writing the word constant before, that means you can't change it. So if I wrote down on here, constant, not sure if I've got enough space, constant age, now I couldn't change it. It's fixed. Right, the next thing we need to do, we have variables, we can assign values to them, that's great. But what we really want to do is we want to have the user get involved and be able to make some decisions. We want to allow them to input values, and we want the system to output it back to it. Essentially what you're talking about is a user, impressive drawing right there, and we have a system. This is represented by my amazing drawing of a computer right here. What we have in a computer program is essentially a conversation that goes backwards and forwards. The system prompts the user to say something or do something. The user does it. The system responds in some way. It feeds back to it. And we continue this cycle backwards and forwards. Now, this applies to any type of program. This could be FIFA, where you push, the system presents you a picture of the pitch. You decide to move the player. It responds by moving it backwards and forwards. It could be to diagnose an illness. The system asks you a question. It says, please put in your symptoms. You just say that, I don't know, you have a fever. It's inputted into the system. It makes some decisions and then puts it backwards. So please keep that in mind. Programs are often conversations backwards and forwards between the system and the user. And it's the human-computer interaction that really sets up this whole thing. Now, why don't we have a quick look at actually our problem here. So we'll get rid of my fantastic drawings and we'll have a look. So what does the problem say? Well, if we read along, it says, please write an algorithm that requests for a user's name. So straight away we know the user will have to input their name and how many hours they sleep at night. Okay. The system should provide a personal message of how many hours per week have been slept. Okay. Now, for the user to know they need to input a value, the first thing has to happen is the system has to ask the question. And the way that works is we use a command up here. See this one here? An output. An output means that the message will be sent so that the user can read it. And then afterwards, the user can input their value backwards. I will use blue for these commands. So let's put it in here, and I will conventionally use capital letters for these command words. I'm going to output the question, hi, and maybe we should just ask for the person's name. Now, that's the system outputting a message to the user. The next thing that has to happen is that the user has to input it, but we have to store it somewhere, and we're going to want to store it in a variable. The variable I think we should just use is a name, because it is the name of a person. And then we're going to say that it's stored, and the way you take in the user's input is you literally write user input. When this program runs, it will ask the question, what's your name? And then the user's input will be stored in name. So just like in algebra, when x represented some number, well, now name represents somebody's actual real name. It could be Bob, could be Rachel, could be anything. Now we're not finished, because the other thing it asked us to do was ask how many hours per night they slept. So we're going to say output again. So the system's going to ask the user how many hours does the person sleep a night? Do you sleep per night? Now that should have just fitted on. Unfortunately, I've misjudged my handwriting size, but that just should be on one line there. So how many hours do you sleep per night? Again, we'll need another variable to store that value. So why don't we say hours, and then let's use camel case, per night. You see that? By using the capitals, it's quite clear how these are all made up. And we just say, again, user input. And that's going to allow hours per night to store it. Finally, I need to output how many hours per week. Now there's 7 days in a week. So what we need to do is multiply that number by 7. So I'm going to have a new variable, hours per week. And this time, we're going to do something we haven't done before. We're going to assign it a value again. But this time, I'm going to take the variable of hours per night, and then I'm going to use it. How am I going to use it? Well, I'm going to times. And to times, you do a star symbol, and we times it by 7. So if you can see what happens here is they'll input the value in hours per night. Hours per night is times by 7, and the value of that is now stored in hours per week. Now, if I run this code, it hasn't quite got me to where I want, because I need to output this value. Remember, it's a conversation between the system and the user. The user has now provided the inputs that the system needed, and it's calculated the number right here in hours per week, but we need now to output it. So here's what we're going to do. We're going to use an output, and we're going to do something new. We're going to say, hi. It stipulated it wanted a personal message. We can use the variables that we've defined before in this answer. Let me show you how. We go plus, and then we use the variable that stored the person's name. What that's going to do if the person said their name was Bob, here it will now say hi and then add in Bob. And it's going to make it a bit personalized for us. And then we say, you sleep for, so we're continuing the sentence, and then we're going to add in the hours per week. Now it's not going to literally put this word hours per week in here, it's going to give the number. So when we run it, let's say somebody added in they slept for, let's say, 8 hours a night. Well, what's going to happen then is that hours per night would store 8. We times that by 7. So that is 56, I believe, in hours per week. So here it will say, hi, Bob, you sleep for 50, what did I get up to? 56. And then if it just said 56, that wouldn't be very good English. So I think we should finish this off by doing plus, whoops, wrong color, plus hours per week. And then that will work quite nicely. Okay, guys, I'm turning it over to you. It's your turn. Please write this problem in your book. Write pseudocode for an algorithm which calculates how much money a student will need to buy a meal and 2 drinks. Remember, it's a conversation. What will the system have to output? What variables will you use to store the user's inputs? How will you calculate it? And then finally, how will you output this value? Best of luck.